webinar today. My name is Matt Jacobson, and I am the Online Learning Coordinator for the Learning Technology Center of Illinois. I'm glad you could be here with us today, and I'd like to remind everyone this webinar is being recorded today. Recordings will be available within 24 to 48 hours on our YouTube channel. Illinois PD credit is available to those attending our webinar live today. An email with a link to the evaluation form will also be sent to the email address you have provided us within 24 to 48 hours as well. If you have any questions during the webinar today, I'll be monitoring the chat. Please type your questions into the chat or the Q&A, which you can access using the buttons at the bottom of your screen. If you're using the chat feature, please click the little blue button there to change the drop-down menu from host and panelists to read everyone, so we can all read your questions and benefit from the responses. Without further ado, let's get started. Today, we are pleased to welcome my colleague, Joe Cipfl, who is the LTC's Regional EdTech Coordinator for the Southern Illinois region. Joe, go ahead and take it away.
Thank you very much, Matt. Welcome, everybody. Let me one last time drop our slides into chat. So slides are right there in chat. Please click on that link that'll take you today to today's slide deck. And please hold on to it and save it for after the session today, because it is filled with lots and lots of great resources that you will find very useful. Let me take a moment to share my screen. And there we go. Give me just a moment here to pull up my chat screen so I can see it, and so that I can see all of you as well. Okay, I have everything here on my end, good to go. So we are ready to start. Excuse me. All right. Welcome to 3D Fundamentals, everybody. We're going to talk 3D printing today. We're going to talk about some of the basics of 3D printing. We're going to talk about creating a space in your classroom for 3D printing. We're going to talk about software to use for 3D printing. I'm going to make some recommendations about some printers, and then finally I'm going to share some curriculum basics. Now, just one little word of warning here at the beginning, and that is I'm probably going to go about an hour today. I know that we're scheduled here for 45 minutes, but this really is going to take an hour. So I'm just going to give you a little bit of heads up right at the start. Obviously, if you do need to go, that's completely fine. You can certainly watch the recording later, but we are going to go about an hour. As Matt said, my name is Joe Cipfl. I'm the Regional EdTech Coordinator for the LTC for Southern Illinois. As you see there in blue, I work with 8 ROEs and 177 school districts and about 5,500 teachers in the Southern Illinois region of the state. It's literally my job to support you. So if you do have any questions or need support or guidance after the session today, please feel free to shoot me an email. You can follow me on Twitter at LTCJoeC, but please understand that I am definitely a source of support and resources for you. So please feel free to reach out. Also, remember that the LTC is really your one-stop shop for all of your ed tech needs. We have great online courses. We have the free webinar series every week. We've got a fantastic online community. We're on all the socials at LTC Illinois. And again, if you just need PD, check our events page, because we are hosting dozens upon dozens of workshops and ed tech sessions for you. So again, please consider the LTC a resource for sure. Okay, now that stuff's out of the way, let's talk about 3D printing. So really, the time truly is now to take your technology integration to the next level with 3D printing. And honestly, many school districts are pretty flush with money to spend on ed tech right now. Let's help our districts make wise purchases. But please do consider the integration possibilities of 3D printing. Okay, now understand that this slide deck that I'm presenting to you today, this is my 1 hour webinar session. I have an expanded version of this session where we go into great detail on all of the topics that you see here on screen. So I do a full 1-day session, or I even do an intensive hands-on 2-day session covering all of these topics. So hopefully this just really gives you a nice little introduction, and then you'll be ready to take the next step and do some hands-on training. Okay, so we're going to talk about some basics. Then we're going to talk about software and apps and tools, creating a makerspace, talk about some printers that I recommend for teachers, and then finally some curriculum integration. Okay, so let's talk about the basics of 3D printing. And so let's get to the most rudimentary level. What is 3D printing? Well, it is a manufacturing process. It is additive layering manufacturing is exactly what it is. Now we think of 3D printing as this emerging new technology, but it's really not. 3D printing has been around for about 35 years. However, it came out of patent about 10 years ago. And so that opened the world of 3D printing to a much wider audience and really brought it in to the education sphere. So again, we think of it as emerging, but really it is a very well-established tech already. Now, as I said, we consider 3D printing additive layering manufacturing. So you can see here on this little video that I have on screen that what you see there's a little frog being printed up on one of my printers. And so basically, if you want to think about the schematics, the engineering of a 3D printer, let's take a look at a schematic of it. So the 3D printing process starts with a filament, a spool of plastic filament. So we start with 3D printer filament. That plastic filament runs through an extruder and into what we know as the hot end, a heated nozzle, where that filament is immediately melted. That melted plastic is deposited layer upon layer on a typically heated print bed, and those 2D layers build up to create a 3-dimensional object. And so that is known as FDM printing, fused deposition modeling. There's SLA printing too, and that's a resin type of printing. That's not what we're going to be talking about today. Today, we're going to be talking about the FDM style of 3D printing. And again, fused deposition modeling, just one melted layer of plastic built up upon the other until we have a 3-dimensional object. So how does the 3D printing process work? Well, really, we can describe it in 3 pretty simple steps. First, we start with a digital model, a 3D model. So where can you get that 3D model? Well, you can design it in CAD, or you can download it off of the internet, or you can scan it with a 3D scanner. And we'll get to more specifics here in just a second. So we start the process with the 3D model itself. Then that 3D model is then opened in slicing software. So we open that 3D model, which is typically an STL file, in slicing software. And that divides up that object into layers so the printer knows how to print the object. So first we start with the model. We then open that model in the slicing software and slice it. And then that code is sent to the printer for printing. And so that after the slicing software renders that image into slices, we send that code to the printer to be built layer upon layer. Now, I've got a little bit more of a detailed slide on that. So let's move down here to slide number 11 if you're following along. So here we have 3D printing in 3 steps. One is design. So we have to start with a 3D model file. That's typically an STL file. And we can find those files or we can design those models as well. So when you're just starting out printing, probably the easiest way to start out is to go to the many repository websites that are on the internet and download existing STL files. There are great websites like Thingiverse and Prusa Printers, and there's links right there on slide number 11. And there are millions upon millions of 3D model files available that you can download and print up. Truthfully, I really started there, and I've kind of stayed there too. I've not gotten into a ton of the design software yet. However, I do download things from the internet all the time. So first step is to download off the internet. Now, also you can design objects using CAD software, computer aided design. And there are some great tools and software packages out there that we'll talk about for CAD. And then the third way is to scan an object with a 3D scanner. Now, we're not going to talk about 3D scanners today here at our webinar. That's a little bit more of an advanced concept. But I do have a 3D scanner that I'd like to recommend, and it's just a great little smartphone app, and it's called Polycam. And Polycam is a great 3D modeling app that you can easily install on your smart device. And it's really, really good. Okay, so step 1 is design. Get your 3D model file. Step 2 is slice. So now you need to take that 3D model file, that STL file, and you need to divide it up into very fine layers. And they're tiny little layers, typically 0.05 to 0.3 millimeters. So they're very, very thin layers. And those layers are laid down on that print bed by that hot end, layer upon layer upon layer, until you get your 3D object. There are great slicing software packages out there, and the 2 best ones that are on the market, Cura and Prusa Slicer, are free and they're open source. And we'll talk about them in detail here in just a moment. So that's step 2. Step 1 is design. Step 2 is slice. Step 3 is print. Now you have sliced that object. You're going to send that code, it's known as G code, to your 3D printer for printing. And so some printers are network enabled, so they'll connect to your Wi-Fi and you can send the code to the printer over your Wi-Fi if it's a network capable printer. Other models of printers have a flash drive, a USB drive that you just save your file to that and then plug it into your printer and print. And even other printers use an SD card instead of a USB, so that you just download that file to your SD card and then just plug it right into your printer and print. So again, it's really not quite as complicated as a lot of people think it is. All right, so let's talk a little physics next. So let's talk the physics of 3D printing. Now, what you can think of when you think of 3D printing is it's kind of like an Etch-a-Sketch. Do you remember the Etch-a-Sketch? Did you have an Etch-a-Sketch when you were a kid? So I had an Etch-a-Sketch, and you know how the Etch-a-Sketch works, where you turn the left knob and the little line goes up, and you turn the right knob and the little line goes across. And if you turn them both at the same time, they go diagonally. Now let's just add a third dimension to that. Let's add a third axis to that. And that's exactly what 3D printing is. It is constructing an object across the X, Y, and Z axis. Think of 3D printing as a complex glue gun. That's a great way to describe it as well. you've got the x-axis, which is your left to right axis. You've got your y-axis, which is your front to back axis. And you've got your z-axis, which is the up and down. And so when you slice that object, that slicing software tells the hot end, the nozzle and extruder, where to go in that three-dimensional grid. Now, some 3D printers work in that the build plate moves front to back across the y-axis, and then the gantry, where the hot end is, moves side to side on the x and up and down on the z. Other 3D printers work a little bit differently in that the build plate moves up and down on the z-axis, and the hot end on the gantry moves side to side across the y and front to back across, across the x side to side and across the y front to back. So again, you just need to take a look at your printer and just see how it works. And it really will fit this description regardless of what printer you're using. Okay, I've got some terms here on slide 13 and 14. I'm gonna, to save us on time, I'm not gonna go through these one by one, and I've already described several of them. But just understand a few terms here. Your build plate is where the print builds up upon. I just said the gantry is where which is the carriage that holds the hot end. The purge line is a line of filament that is spit out before the print starts to make sure that that hot end, that nozzle, is completely clear. Moving down to slide number 14, we're going to get into some design considerations here, where we're going to talk about rafts and support materials and shells. So we're going to move right along to slide number 15. So now let's talk about the components of a 3D print. So first we have infill. Now take a look at these graphics that you see here on screen. Infill is the internal support that helps the 3D object hold its shape. And so infill is adjusted by density. So a denser infill is going to create a stronger object. So really, you need to just do some experimentation. And this is really where the trial and error piece of 3D printing becomes so very useful in the classroom. So you'll see on that picture that there are some infill patterns that are rectilinear. There are some infill patterns that are gyroid. There are some infill patterns that are honeycomb shaped. And so some infill patterns do better with geometric objects. Some 3D or some infill patterns do better with sculptural objects. And sometimes if your object doesn't need a lot of strength and support, you don't need to have a very dense infill, because you need to remember that the 3D printing process takes a lot of time. A print of any size can take multiple hours. Just to give you some perspective, I've got a couple of 3D printed objects here in my office. Here I've got, if you're taking a look at your webcam there is a human skull that I printed. Can you tell I was a biology teacher once? But just to give you some perspective, a print of this size is about a 70-hour continuous print. So the printing process can definitely take some time. And the thing that you need to remember is that if you have a denser infill, that's going to require more material. That's going to require more time. Those are things you want to consider when you're designing and when you're slicing those objects about print time and print quality. Okay, so let's move on next to layers. Layers are the slices, so to speak, of your printed object. So thinner layers mean more detail. Thicker layers mean less detail, but the thing you need to remember is thinner layers require much more time, where thicker layers require less time. So if it's a sculptural object like my skull here, I'm going to go with thinner layers and just sacrifice the time because I want those layers to not be very visible. I want there to be nice sculptural elements of the object. However, if I am printing something that's geometric or structural or practical, I'm not going to need that level of detail. I'm not going to really mind so much that I can see those visible layers. So I can go with thicker layers and save myself some time. So again, those are just all little tweaks that you can make during the design process. Okay, next we have shells. Shells are also known as perimeters, and they are the exterior walls of the print. So again, thicker walls means a much stronger structural object, but those thicker walls do require more time. If you go with thinner walls, sometimes your object might have a little bit of flex to it as well. And you might want an object that has a little bit of flex to it. So you would go with thinner walls. There's also flexible filament that's really interesting and to use too. And I'll make some filament recommendations here in just a bit. Okay, next we have the rafts. So what rafts are little helper support structures that help the 3D printed object adhere down to the print bed. So if you're taking a look on screen, if you can see where my cursor is dancing around here on screen, those little support structures on the corner of that box, those are rafts. Now, why would you use a raft? Well, you use a raft to help that object stick down to your print bed more securely. It helps with adhesion. So sometimes when you're printing 3D objects, there's not a lot of surface area to stick down to your bed. So as the printing process is going on, if there's not a lot of surface area to stick down to the bed, that object could come dislodged from the 3D printing bed. And then you've got a big mess on your hand because now the printing process isn't going to work and the object has broken loose from the bed. And now you've just had a failed print. Trust me, if you've been 3D printing for any length of time, or if you're new to 3D printing, you will experience failed prints. Happens all the time. But in my opinion, as a classroom teacher myself, those failed prints are always the best learning experience because you can backwards engineer what went wrong. So it's great for troubleshooting. It's great for critical thinking. But sometimes there are some 3D printers out there that have sometimes leveling issues. The 3D printers that I'm going to recommend to you today all auto level. So that's one headache that you don't have to worry about. But sometimes 3D printers can be tricky with their leveling. And so rafts can sometimes help if you have a 3D printer that does have some leveling issues to help that 3D printed object stick down, adhere to the print bed better. Okay, moving on to slide 16. Next, we have overhangs. So overhangs are those they are those 3D objects, or they are the components of a 3D object that hang out into space. So if you're looking at my skull here, it would be something like you see on this orbital bone, this jawbone here. Or on the example that you see there on screen, it would be the overhangs of that T that you see right there. Well, you need to remember that the printing process happens from the bottom up. So if you have overhangs, if you have structures that hang over about 60 to 70 degrees, you need support from underneath. Otherwise, your 3D printer can't just spit out filament and print into thin air. It's printing from the bottom up, so it needs to be supported. So if I was printing this T in this orientation, this orientation on the left side, I would need support over those 90-degree overhangs. Otherwise, those crosses on the T could never print into thin air. However, would you ever print a letter T in this orientation? I know that I wouldn't, because I could just flip it upside down and print that T upside down, and then I would need no supports. Supports are these scaffolding-like structures that are temporary, that are built to support structures from underneath that you peel away after the print is complete. So again, the orientation of your model on your print bed when you're working with the slicing software is important, because you want as little support structures needed as possible. But you can see here in the middle, supports are these removable scaffolding-like structures that provide support for any structures that overhang or seem to be in, hanging in midair of more than about 60 to 70 degrees. And so I'll show you what supports look like here in just a moment. Now, lastly, we have bridges. And what bridges are exactly what they say they are. They are the underside of the print that is supported at the ends, but not in the middle. And so typically, most 3D printers can print a bridge no longer than about 50 millimeters without support for underneath. So, if you have a long bridge, so if you have a long structure on your print that is supported on the sides, but not in the middle, you need to determine what the bridging tolerances are on your 3D printer. And there are great test prints that you can print to test out those tolerances. And I'll show you exactly what I mean by that. So let's take a look at the next slide. So I'm going to show you this video here. So that you pay close attention to the video here, and you can certainly watch it after the session today, but this is an example of bridging. And so this is one of my printers. I took this video. This is the Prusa Mini printer, which is one of my absolute favorite printers. But take a look at what bridging is. So what we have here is a double helix, and this is a bridging torture test. So I want you to watch this video here real quick. And so you can see there that the nozzle is laying down that filament. Watch right here. Boom, right there. There's one single layer of filament. Now there's two, and now there's three. That is a great example of bridging. And so what you see on screen is a double helix. And as a former science teacher, I would definitely be using this as an example during my genetics unit at the double helix shape. But what this really is this is a torture test for your printer to determine how long your printer can bridge a space without support from underneath. And so you can print these test prints and determine how long your printer can span a space without support from underneath. So if I would see some sag, or if I would see layers breaking off, I would know my printer can't handle that wide of a space, and so I can scale that model down and then test it again. So again, once you really have your printer dialed in and well leveled, it should be able to print a fairly good space. And that's why I do love these Prusa printers so much, because they do have great dialed in leveling. Now, just as I'm talking about printers, I'm going to start talking more about printers here in just a second. Please understand, I am brand agnostic when it comes to printers. I've tested several printers. I have about 6 printers that I use in my workshops. I've researched several printers, and I recommend what works regardless of brand. No one's paying me to recommend their printers. I recommend what works and what I would use in the classroom myself as a teacher. So do understand that the stuff that I'm recommending today comes from a completely objective space. Okay, now let's talk next about support. So I was saying, remember, when you have an overhang of approximately more than 60 to 70 degrees, you need support from underneath, because your printer can't just print filament into thin air. So you can see here on slide number 18, this is a Triceratops skull that I printed. And you can see right there where my cursor is moving around, that jawbone, you just can't the printer couldn't print that into space. So you can see these scaffolding-like support structures that are printed under that area. And then those support structures just peel off of the print after the completion of the print itself. So you just pop the print off the print bed, and then you just peel those support structures away. Sometimes those support structures can get kind of stuck, so you might need like a needle nose pliers or some tweezers to pull that off. So if you're printing something really intricate, sometimes you have a little bit of post-print processing to do to remove those support structures. My skull here had lots and lots of support structures that I had to peel away after the print completed. And I'll show you what those support structures look like here in just a bit. Okay, so let's move next to filament. So let's talk about a couple different types of 3D printer filament. Now, something to remember too is when you're budgeting for a 3D printer, don't forget to budget for future filament purchases, because obviously filament's going to be an expendable resource. So you need to replenish those supplies. And so when you're budgeting, always remember there's going to be future filament purchases. Now, there are some great filament brands that are available on Amazon. And so you can find a 1 kilogram spool of 3D printer filament for about $20 a spool on Amazon. There are some great filament brands that are good. Overture is a great 3D filament brand. Hatchbox is another really good 3D filament brand. And to put it into perspective, my human life-size skull here is about maybe 1/4 of a 1 kilogram spool. So the spools go quite a long way. Now, the most common 3D printer filament is PLA. And so if you're on the slides here, if you click on any of these links on slide number 20, they will take you to a dedicated page all about that filament. So, do a little bit of research, but understand that PLA is the most popular, the most commonly used. If you're using 3D printer in the classroom and you're not a CTE teacher, it's what you will use probably 95% of the time. It's easy to print with. It is a low temperature filament, so it prints somewhere between about 180 and 230 degrees Celsius. Remember, everything here in 3D printing is the metric system, so it's a great metric system lesson as well. It's low temperature. It's easy to print with. It is odorless, so it doesn't give off any VOCs or fumes, so you don't have to have any sort of venting. It's perfect for classroom use. And it's about 70% cornstarch. So when you print with it, it smells like caramel corn. Again, it doesn't give off any fumes at all, so completely harmless for printing in the classroom setting. Next, we have PETG, PETG. Now, PETG is kind of a really cool in-between ABS and PLA. ABS plastic is very, very strong, but not easy to print with, and it gives off fumes, so typically not very classroom friendly. PETG is kind of the middle ground between PLA and ABS. PLA is great, but it can be brittle. So sometimes if you drop an object, it could break. It's not super heat tolerant. So if you leave a PLA printed object in a hot car during the summertime, it could not melt, but definitely droop or sag. PETG is stronger. It's a higher temperature printed filament. It handles higher temperature tolerances, and it's considerably stronger than PLA. However, since it is a higher temperature filament, it can get stringy. It's not always super easy to print with. It's more of an intermediate kind of printer filament. So start with PLA, and then you can kind of maybe graduate up to PETG. Please understand, though, that PETG sticks down to your print bed much more strongly than PLA. So be careful when you're removing a PETG from your print bed that you don't damage the print bed itself, because the print beds typically have either a metal or a glass sheet that you print on. Some of these steel sheets that we use on the printer beds have like non-stick coatings on them, and that PETG sticks so well that it can maybe rip off that coating. So in some instances, you might put a layer of glue stick down to be a release agent to pop that print off. Other times you can take the printed object on the print bed and stick it in the freezer maybe for a minute or two to help ease it off of the print bed. PLA Plus, Nick, is good, and I've just started using it, and that is a great, stronger PLA. I just started using the Overture PLA Plus, and I have liked it a lot. I'm gonna, once summer rolls around, I'm gonna stick something in the hot car and see how well it does in there. But you're absolutely right. I am really liking PLA Plus instead of PETG. Just easier to print with, especially lower temperatures. Okay, ABS is the most well-known plastic on earth. It is what almost everything that's made out of plastic is. All of the plastic stuff that's in front of you right now, this second, is ABS plastic. ABS plastic is used for injection molded plastic. It's very strong. However, when you're printing with it, it gives off VOCs and fumes, so not for classroom use. You would need a vent hood if you were maybe in a science lab. If you are a CTE teacher and you're working in a shop, certainly a ventilated shop is going to be fine. Now, if you do print with ABS, that does require a couple things. It requires an enclosure, because you can't print with an open frame printer because you need a higher ambient temperature for layer adhesion. Also, it's a high temperature print, so you print at a much higher temperature, and it does give off fumes. So again, you need an enclosure and you need ventilation. So ABS is definitely a much more advanced level kind of plastic. But if you are a CTE teacher, if you are teaching engineering and you want to build for structural strength, ABS would certainly be the way to go. Last, we have nylon. Nylon, again, is very, very strong, even stronger than ABS, but tricky to print with, stinky, gives off VOCs and fumes, and does have layer adhesion issues. So you need an enclosure, you need a higher ambient temperature, you need some experience at printing. But again, in the engineering classroom, in the CTE classroom, in the industrial tech classroom, nylon would certainly be a great material to print with, because you can print functional structural objects. Again, you do have more options than this too. You have many kinds of infused filaments as well. There's carbon fiber infused filaments that are super, super strong. But some of those infused filaments can be abrasive. So you need a hardened steel nozzle rather than the typical brass nozzle that's on a 3D printer, so that the filament doesn't abrade the nozzle from the inside out. Okay, Nick asks, is the PLA Plus worth the extra cost? I don't know yet, Nick. I will after I do some testing on that PLA Plus. I've been using the Overture brand on Amazon. So the Overture brand standard PLA is about $21 to $23 a spool, and the PLA Plus was $28 a spool. So it wasn't that huge of a price difference. But I'm going to do a little bit of testing here, and I'm going to see how strong it is and how heat resistant it is, because those are the two things I'm going to be looking for most. And how unbreakable, because sometimes PLA can break fairly easily. Okay, so how are we doing on time? We are about a half an hour in, and we're only done with part one, but we'll move quickly through the next three parts. Okay, so let's talk next about some software. So we're going to talk about some design software. We're going to talk about slicing software. Now, What you do need to understand here is that 3D printing software is not very Chromebook friendly. So you're going to need PCs or Macs to install some of this software. Tinkercad, which is a web-based CAD package, is Chromebook friendly because it is browser based. But really, that's about it when it comes to the software. You are going to need a PC or a Mac, and they are dedicated programs that you will need to install on those machines. But my guess is your district might have some old PC laptops sitting around that you could certainly install this on, or old desktops if you have gotten rid of some computer labs too. Okay, so as I was saying previously, when you want to get a 3D model, you either design it in CAD, you scan it with a 3D scanner, or you get the 3D printable files off of the internet. So let's talk about downloading the files first. So there are some excellent repository websites where you can go and search for and find STL files. This is how most people get their start with 3D printing. This is how I got my start with 3D printing. Just to give everybody that's watching today a heads up, about this time last year, I didn't know how to 3D print. I taught myself how to 3D print during COVID. I was stuck at home, working from home a lot in the last 18 months. And so I made home work for me. And so I taught myself how to 3D print and developed these sessions, and now I'm providing training. So it's been such a great experience. But when I started, and still even now, most of the stuff that I'm printing, I'm finding on the internet and printing on my printers, making maybe little design tweaks here and there, but not a whole lot. So probably the two best repository websites for STL files is Thingiverse and Prusa printers. So these are links here on slide number 24. So you can just click on those logos and they'll take you to the websites. Thingiverse is great. Thingiverse has about 2 million STL files. So just a huge, huge repository. It's a MakerBot website. So it's really, really good. It is a monster of a website. So sometimes it can be quite cumbersome to search. The search utility is not the best on the website. So just understand that it's a little clunky sometimes when you're searching things, but there's a huge number of models there. Prusa Printers is a relatively new repository website from the Prusa research company. It's smaller with only about 100,000 files, but the files are really good and they're well vetted. And it's a really nice and easy to navigate website. Now, there are a couple more. Pinshape I like. Thangs with an A. Thangs is pretty good as well. I have Cults on here too, but just do be aware, Cults is not super school appropriate. Cults has some great models on it, but they do have a rather extensive adult section. So it's something you probably are not going to want to use with your students, but you can certainly search Cults and find some great 3D printable files. Cults is a little bit different where some are free and some are for purchase, whereas Thingiverse and Prusa printers, they're all free. But like I said, Thingiverse and Prusa printers are my two favorites and the ones that I definitely use the most. Okay, now a couple of downloading tips. When you're downloading files from the internet, do definitely open, when you slice these objects, so when you open them in your slicer, before you send them to your printer, definitely look through the print preview section and look to make sure that everything looks right in the design, because these are files that people are just uploading to the internet. So nothing says that they're guaranteed to work or print well. As with anything that is uploaded to the internet, you never know entirely what you're going to get. And just like some information on Wikipedia isn't accurate because people are uploading to it, sometimes the models that people are uploading to these repository websites are not going to be top quality. So definitely, look at the print preview prior to printing to make sure that everything looks right, and that the design is accurate. Thingiverse has an excellent education section. Remember, Thingiverse is a MakerBot product, and MakerBot has a great education line of printers. So take a look at those education sections, because you'll find lesson plans and lots of really good examples of how to integrate with students. Look at the comments section. Look at the makes. So when someone makes an object that they downloaded from Thingiverse, they can actually post pictures of what they made and then offer tips, offer how they printed, the resolution and the speed and all of that kind of stuff, and what filament they used. If there's problems with the design, they might put a comment in there that said, hey, I noticed this problem, so I solved it this way. So those comment sections can be very, very helpful. Also, as I said, Thingiverse is a monster website. So use that search function in there when you're searching for things, because you're literally going to just be paging through millions of files otherwise. Okay, then now there's CAD. So if you want to try your hat at some design, you've got some options here. So CAD software, computer aided design, goes all the way back to the 60s. It's used in architecture. It's used in engineering. It's used in visual arts. So there are some really good CAD software packages out there, and lots of them are free for teachers and students. So probably your go-to tool for introducing students to CAD would be Tinkercad. So Tinkercad is an Autodesk product. Autodesk makes industry standard quality CAD software, and Tinkercad is a web-based design tool. So it's a web-based design tool. It is SOPA compliant. So it meets SOPA compliance for your districts to use with students. And it is a great entry point into design software. And what's so nice about it is browser-based, so it will work with your students on Chromebooks, and it's Google Classroom integrated, so you can share right to your Google Classroom. So if you're using Google Classroom as your learning management system with students, you can push right from Tinkercad into your Google Classroom to distribute information to your students. But like I said, it is a fantastic entry point for design software. Now, another good entry one is called SketchUp. SketchUp is not free, so it's subscription based, but it's a good and complete beginner package when it comes to designing. So again, it's good, but I would probably start with Tinkercad simply because it's free. Now, really, honestly, after your students get the hang of, or you get the hang of Tinkercad, your next logical step is Fusion 360. So Fusion 360 is, again, another Autodesk product, but it is industry standard, professional grade CAD software. It is what the professionals are using themselves. And so you can then move on to that. And what's so great about Fusion 360 is that you can get a free subscription for students and teachers. So there is free subscriptions for educators. It's kind of funny. What they will do is they will give you a 1 year, a quote unquote 1 year subscription, and then they will just simply forget to let it expire. So basically what happens is you sign up for a 1 year educator or student account, and it just doesn't expire. So it is free to use for educators and for students. And then my next one that I would recommend is Mesh Mixer. And Mesh Mixer, again, is another Autodesk product. It is free. And what it does is it is kind of, they call it the Swiss Army knife of design software, because it helps process the object. It allows you to smooth things or clean up a design. So oftentimes designing is your app smashing, and you're using a series of software where you might start a design in Tinkercad and go with something simple, and then maybe open it in Fusion 360 to do some more complex designing. And then let's say that my skull here that I'm designing needs some smoothing on the top. I'm going to open it in Mesh Mixer and lay down some mesh polygons to smooth that object out. So again, the design side of 3D printing is a whole nother workshop, to be honest with you, and something that I will be doing in the future for sure. Great information, Stephanie, that SketchUp is free for school districts. Fantastic. I'd love to hear that. Okay. Now let's talk next about the slicing software. So you've got this 3D object file that you've downloaded from the internet. So now how do you take that object from virtual reality to actual reality and print it up? Well, you need to slice it. So you need some slicing software. Now, before we get into the slicing software, let's talk about a few design considerations. Okay. So what you need to think of when you are slicing your object is the orientation of that model on the print bed, whether you have overhangs that need support, your temperature for print bed adhesion, and making sure that that nozzle is calibrated down to your printer really, really precisely so that it lays down first layers really well. You got to think about your resolution. That's the thickness and thinness of your lines. Like I said, thicker layers mean less time, but it also means less detail. Thinner layers means more detail, but longer print times. You need to think about your infill. That's your interior support, how much interior support that object needs. You need to think about your print speed and your temperature. So, certain filaments print at different speeds and at different temperatures. And if you see like your print getting really stringy, you know that that temperature is probably a little too high or the speed is a little too fast. You also need to think about your calibration, how you have your printer calibrated so that that nozzle is right next to the print bed when you're printing. Now, these can be overwhelming. And I know that I just hit you with a bunch of stuff here, but do understand that each one of these links on slide 31 will take you to a dedicated page about that design consideration, about that design element of a print. And what's so awesome about this slicing software is that there are default settings for everything. So when you first start 3D printing, and you open an object in your slicing software, there are default settings. So you can just go with the default settings for PLA filament and then start your printing process. And then as you get the hang of things, you can start to make little tweaks to improve the quality of your prints. So print with the default settings at first, learn the process, and then you can start making little tweaks like, oh my gosh, I noticed some stringing happening on that print. So I'm going to dial down the temperature just a little bit. If I'm seeing visible layers in the print, or maybe a shift in the layers, maybe it's not adhering down quite as strongly that I need to. And so I have to move my nozzle down for the calibration. So again, you've got default settings, use those default settings. Okay, now let me buzz through the software here. So these are all links. So kind of the go-to slicing software, the granddaddy of them all is Cura. Cura has been around for a long time. It is open source. It is a great slicer and very simple to use. Prusa Slicer, to be honest, is my favorite one. I think it's more feature rich and easier to use than Cura, but it is also open source. So again, you can download these software packages by just clicking on these links, and they will take you to the software. So Cura is good. Prusa Slicer is good. Simplify 3D is really good, but again, that one is subscription based, and there is not a free version of that one. It is $150 for 2 subscriptions. And then there's Slicer, and Slicer is an old G-code generator that the Prusa Slicer is built on, and it is an older version of Slicer. It's definitely more code based. It's definitely more text based. So not quite as visual. So again, it doesn't. It has options that you don't see on other slicers, but it is definitely more tricky to use because it's not quite as a visual. It's much more code based. Okay. All right, now let's buzz through these last couple of options here. So creating a 3D printing workspace. So basically, kind of the rule of thumb when it comes to 3D printing is when you create the space, there are 3 schools of thought on how to create your layout. You have got the makerspace setup, which is where your printers are out amongst your students, scattered around the room. You have the general printing area set up where you have maybe a table set up at the back of your room where students can print, or you have an instructor's printer if you maybe just only have one printer and you're using it for demo. So you really need to just determine your needs and figure which setup is best for you. As a former biology teacher, I would probably use the general printing area setup in my classroom. Now, a few things about printer placement, whether you're going to put that in a classroom or whether you're going to put that in a communal space, and some things to think about there. Also some do's and don'ts, and this revolves a lot around filament. Filament is what we call hygroscopic. It absorbs moisture from the air. So you need to store your filament in airtight containers that have some large desiccates in them to keep moisture from building up. We live here in Illinois where there's lots and lots of humidity during the summertime. So definitely store your filament in, when you're long-term storing your filament, put it in some airtight bins and put some great big desiccates in there to absorb that moisture. There are also filament dryers that you can buy, or you can convert a food dehydrator into a filament dryer. Okay. Now, I also have some recommendations for some tools. Obviously, there are going to be some tools that you need here. So on slides 41, 42, and 43, I've listed out the common tools that you're going to need when 3D printing or demonstrating in class. So take a look at those. Or you can buy a 3D printing tool kit, and there's lots of great ones that are available. This Matter Hackers one is awesome and available on websites like Amazon and things like that. Okay, now let's wrap up today with the printers that I would recommend for classroom, and I'm going to share with you some resources. And so I just need 5 minutes of your time for that. Okay, so when it comes to choosing the best 3D printer for your classroom, do your research. Or you can let me do the research for you, because that picture right there on slide 48 is my living room. I built a makerspace in my living room, and my printers live at my house where I tinker with them pretty much 24/7. So I've got some recommendations for you. So some of the printers that I would recommend include the FlashForge Adventurer 3. It's an excellent printer. It is completely enclosed, and it has a really good price point. In fact, the Adventurer 3 Lite is $299. It's between $299 and $350, kind of just depending on the market at the time. But it's really good. It's a really solid printer. It's a great beginning printer. And it's got really good features that you can see here indicated on the slides. And actually, there are links to all of these printers. If you just click on the logo on the slide, it will take you to those printers. My absolute 100% most favorite printer is this one right here, the Prusa i3 Mark III. It is considered one of the best hobbyist printers in the world. It is absolutely awesome. It is the printer that I printed this skull on. It is my workhorse printer. It is fantastic. It is got a good price point at $1,000 for the assembled printer, or you can buy the kit version and build it yourself for $749. So if you're handy, if this is a CTE class where you are building things and you want to build your own printer, you can. Now, if that is, and what's so great about all these printers that I'm recommending today is that they're all self-leveling. So you don't have to deal with a bunch of leveling issues. And these Prusa printers have optical automatic bed leveling that is second to none. It is so good. Now, if that price point's a little bit too high for you, you could go with the Prusa Mini. So that is a smaller print area, but it is of absolute equal quality when it comes to printers, the printer itself. Great print quality. It just has a smaller print area, smaller footprint, but super reliable, very accurate, and has automatic leveling. $399 for assembled, $350 for the kit version. I have both of these printers. I think that they're excellent. And the greatest story about Prusa is that they 3D print their printers. Let me say that again. They 3D print their printers. They have a print farm of 4,000 printers that are running simultaneously to print all of the parts for all of the plastic parts for their printers. What's so great about Prusa as well is that their printers are open source hardware and software. So you can make clones, or if you want a different color, they make the STL files for their printers available online. And so you can print up replacement parts for your printer for free or change the color scheme of your printer. Okay, the last one that I used to recommend, and I really don't much anymore, is the Dremel Digilab 3D45. It's a great big printer. It's super expensive at $2,000. It's got all the bells and whistles, but I just wish it was a more accurate printer. My Prusas are a more accurate, better print quality than the Dremel. And I would love to recommend it, but I just don't, because there's just too much tinkering and tweaking that I have to do with my Dremel all the time. Nick, no, they're not quite out of the 3D printer game yet, but I would not doubt if they get out of it, just simply because the amount of trouble that my 3D45 gives me. I'd love to talk to somebody from Dremel to see if they have some solutions, because a $2,000 printer shouldn't get out printed by a $399 printer. Now, there are some other great ones that are out there. Ultimakers. The Ultimaker brand of printers are awesome, but they're exorbitantly expensive, and so typically are kind of out of the realm of K-12 education. But if your district has a big budget, you can take a look at Ultimaker printers. They are fantastic, but they're several $1,000s. Creality Ender printers are also quite common, especially in education, but I usually don't recommend them because they're notorious for having bed leveling issues. And the last thing you want to do in the classroom is deal with constantly tweaking the leveling. That's going to lead to frustration. And you know as well as I do, when you get frustrated with tech, you tend to not want to use it. Okay, now last thing, and I'm so glad that you guys are sticking with me, and I'm sorry I'm a little long here, but I totally think it's worth it. Let me offer some curriculum advice and just some curriculum resources, because honestly, you can integrate 3D printing completely across the curriculum. We think of it just as maybe STEM and CTE, but there are social studies applications. There are even ELA and literature applications. Imagine having this skull while we're covering Shakespeare and things like that. So again, there are all kinds of great applications. So I've got some recommendations for integrating across the curriculum here on slides 56 and 57. I've got a few classroom tips on how to better provide those hands-on experiences with 3D printing on slide 58. And now I've got some curriculum stuff for you as well. So these are all great links for some 3D printing curriculum, because if you've been looking, there's not that much 3D printing curriculum out there. Now, if you are looking for ready to go curriculum that's ready to go and you're basically just kind of plugging and playing, you want to go with the Learn by Layers 3D printing curriculum. So that is a canned curriculum that's ready to go and would be certainly a good starting point for 3D printer curriculum, but it's going to set you back $250. So that's a purchasable 3D printing curriculum, but it is a ready to go curriculum. So it would be a lot less searching. But do understand that Thingiverse has a great education website where you can find great lesson plans. The Polar Cloud is okay. It has the Steam Tracks curriculum kits that are also ready to go. Even if you're just looking for resources, the old Kathy Schrock's guides to everything, which have been around since the 90s, is still really good. Kathy Schrock's guide for 3D printing has lots and lots of great resource links for you. So check out that one as well. Now, to be 100% honest, if you want to know how I learned how to 3D print, I learned how to 3D print watching YouTube videos and reading subreddits. Honestly, I mean, you know, I might behave and look and dress like I'm 12 years old, but I turned 50 this year. And so learning stuff on YouTube is not really in my wheelhouse. I remember the pre-internet world. I remember looking things up in the card catalog. I remember what real research is. I also remember how boring rote learning is as well. So I taught myself how to 3D print interacting with social media groups and watching YouTube videos. So what I've got here on slide 60 are some great Facebook groups and subreddits for 3D printing. And I really like Reddit quite a lot for troubleshooting and learning tips and tricks for 3D printing. The subreddit Fix My Print is really, really good, because what I love about that is you submit pictures of your failed prints, and then people recommend what you can do to fix that print. So it's kind of like this crowdsourced troubleshooting to help you when you're struggling. Do understand that there is an enormous global community of printers out there that are very, very helpful. So join some of these Facebook groups, go to some of these subreddits and just start asking questions or stalking and lurking the groups to learn more information. Also, there are fantastic YouTube channels. These are all links on slide 61 to YouTube channels where you can learn about 3D printers. There are reviews and you can learn how to print. The 3D Printing Nerd is definitely my favorite 3D printer channel that's out there. Joel Redding is the guy who calls himself the 3D Printing Nerd. He has a great channel where he prints things, he reviews printers, he offers advice, and really teaches you how to print. But all of these other channels are also very, very good. The Thomas Sands Ladler one is really good as well. But again, look through these channels and just start watching. And then once you get a little bit of the hang of it, you just get in there and start printing and learn from your failures. All right, that is about it. Please remember, if you have any questions, if you need any support, if you want me to expand on any of this, please feel free to reach out. I'm happy to help. Do understand, everybody, that this is my really 1 hour session, kind of summary session of my more intensive hands-on sessions, which I definitely am scheduling a lot of. And I'm not doing 3D printing just in Southern Illinois. I'm doing it statewide, and we'll be doing sessions Northern, Central, and Southern Illinois during the summer and then into next school year. So again, if your district or region is interested in learning more about 3D printing, please feel free to reach out as well.
Again, once again, Joe, thank you very much for sharing your expertise. We will post the recording of this webinar on our YouTube channel within 24 to 48 hours. And also, you should check your inbox for an email from events@ltcillinois.org for a link for our live attendees to evaluate the session for Illinois PD credit. Also, check out ltcillinois.org/events/webinars and sign up for future webinars here during this March month of Makerspaces. Joe, thanks again very much for your time, and we hope to see everyone back here again soon. Thanks, everyone.